Okay, let's look at working out reactions for a UDL. So there's a uniformly distributed load on top of this beam. That's reaction A, that's reaction B. And let's say this time that it's 10 kilonewtons for every metre of beam. That's the strength of the UDL. And we know that the distance between RA and RB, the span of the beam, is 4 metres. First thing we'll do is we have to convert this UDL into a point load. So we've got 10 kilonewtons acting over 4 metres, gives us a total kilonewton load of 40 kilonewtons, if you like. It's the equivalent of 40 kilonewtons in total, because it's obviously 10 times 4. So when you're dealing with UDLs, when you've worked out the equivalent point load, that always sits central to the UDL of 40 kilonewtons. So in our case, you'd then work out RA and RB quite easily, because that would be 2 metres and that would be 2 metres. You won't have to go through the clockwise equals anti-clockwise motion of the last video. You'd just know that RA equals 20 kilonewtons and RB equals 20 kilonewtons. And you do a check, up equals down. So up you've got 20 plus 20, and down you've got 10 times 4, because it's acting over 4 metres, so 40 equals 40, that checks. However, let's do something slightly more awkward then. So in this example, we've got a UDL, and it only runs for a part length of the beam. So that runs for 3 metres, but there's 4 metres between RA and RB. So that's more awkward. Again, we'll keep it as 10 kilonewtons per metre run. So in this case, we'll work out our equivalent point load. Oops. So our equivalent point load equals 10 times the 3 metres it acts over, which is 30 kilonewtons. And that's going to act centrally to that wiggly line. So that's 30 kilonewtons as an equivalent point load. So when it comes to working out shear and bending and all that, which we'll do later, fine, it's still UDL then, but for working out RA and RB, you have to convert it into a point load. So that's acting centrally to there, which means it's 1.5 metres from there, and 1.5 metres from the other end there. But there's still a further metre to go there, because that's 3 metres and that's 4 metres in total. Consequently then, to work out RA, take moments at RB. So we've got our let's do it in another colour. So for RA, take moments at RB. So we've got our pivot here. So we've got RA, that's definitely going clockwise, and then this 30 going anti-clockwise. So clockwise equals anti-clockwise. We've got RA times by 4 metres, because it's 4 metres away from that pivot, balanced by the equivalent point load of 30, that's the whole reason why we worked it out, times by its distance from where it acts to that pivot point. So it's 1.5 add 1, so it's 2.5 metres away. So we've got RA times 4 is of course 4 RA, and it's balanced by 30 times 2.5, which of course is 75. So 4 RA is 75, so RA on its own must be 75 divided by 4. So 75, I'll do it on a calculator, 75 divided by 4 equals 18.75 kilonewtons. Let's work out RB. Won't take long. I'll do it over here, I'll do it in another colour, do it in green. So RB, take moments at RA. Clockwise equals anti-clockwise. Alright, in this case, the pivot, take moments at RA, the pivot's over here. So I've got 30 coming clockwise, and RB itself going anti-clockwise. So I've got 30 times by its distance to the pivot, which is 1.5. balanced by RB times by its distance to the pivot, which is 4. So 30 times 1.5 is 45 equals 4RB. So 45 over 4 equals RB. So 45 divided by 4 equals 11.25 kilonewtons. Let's do a check then. Up equals down. So up we've got 18.75, add on 11.25, has to balance 30 kilonewtons, because that's the UDL times 3. So it's 10 kilonewtons times 3 meters. 18.75 add 11.25 does indeed add 30, add up to 30. So 30 up balances with 30 down. So that's correct. That's essentially the principle of it. Just convert your UDL and it'll always act in the middle of the UDL. So if you had a beam that was cantilevered and you had a UDL acting over a certain distance and a UDL acting over that distance, you'd just convert it. The UDL would, let's use another colour. This UDL would act here, this UDL would act here, but they'd both act exactly in the middle of the run of the UDL, if you like, and then you just work it out as if it was a regular point load calculation. And there you go. So that's working out reactions for UDLs.